Hey everyone, this is a very quick, very short introduction to Vortex. Vortex is a programming language that I wrote in C++. It heavily relies on side effects in the form of hooks, which is what I'll be speaking about today. And it comes with C interrupt right out of the box, so you can write C code and basically run it as Vortex modules. It offers a whole bunch of different things. If you want to have a look at what it does offer, the GitHub page is a really good way to have a look at that. And the Vortex documentation as well is directly in there. So you can have a look to see what Vortex does differently to other languages. But as I said, the focus of today is going to be predominantly on hooks. Now, hooks is basically the bread and butter of Vortex. It allows Vortex to be more of a side effect friendly language rather than shying away from side effects, which is why I jokingly have it described as a dysfunctional programming language. All right, now onto some code. What I have here is a bunch of examples in VS Code that I'll walk you through. So we're going to start with some basic ones and then move on to some more advanced ones, but they're all going to be around hooks. Let me just clear that so there's no spoilers. Cool. So if you direct your attention to example 1, you'll notice a few things. So we have a variable called x with a value of 100, and then you have this weird onChange thing here. What that is essentially we're applying a hook to the variable x, saying that whenever x changes, we want to fire this function over here. Now, the way this works is really under the hood is Vortex will have a look to see if x has any hooks associated to it at runtime. And then once x changes, it injects an object into this e parameter over here and calls that function. So that's exactly how that works under the hood. There's nothing really special or weird going on there, but you do just have to keep in mind how it works throughout this so you don't get confused and foot gun yourself, which you can very easily do with side effects. But what we're doing in this particular hook is we're just printing the object that gets injected at runtime. So if I go ahead and run that code right now, you'll see this is exactly what gets printed. You get an object that has a old value, a current value, and in some instances, for example, if it's just a standalone variable and not an object property, you also get its name. So that's basically it. That's a very basic hook. We've just applied an onChange hook to x, and whenever x changes, it fired this function. Cool. Let's move on to the second example. Let's save that. So the second example is very much like the first example, except the only real difference here is that we're applying the hook to an object property rather than a standalone variable. And as you can see here, we have this color object that has RGB values. And for the sake of our own sanity and for the length of this video, we're just going to apply a hook to the first value, which is the red value. The red property. And what we're doing here is we're essentially saying, hey, if the current value is actually less than 0, we're just going to go ahead and change it to 0. And if it's greater than 255, we're going to change it to 255. So essentially what we're doing is we're capping that color to between the range of 0 and 255. And what we're going to do here is we're just going to erroneously apply a value of 450, which falls above that range to the red property, and print that whole object out and see what happens. So as we expect, red was capped at 255 because of this onChange hook. Now you can imagine this gets really powerful if you want to, for example, expose a type called color to your users, and you want them to be able to change the values arbitrarily, but under the hood, you cap those values to a desirable range. So the user doesn't have to worry about that, but you as the library creator or maintainer can deal with that under the hood with hooks. And actually, I'll give you an example of exactly that in the third example. So I'll just uncomment that. And as you can see here in example 3, I've essentially just extracted that logic of the capping out into its own function called cap color. And then we have a type here. Don't worry too much about how types and things work in Vortex. We'll cover that in a different video probably. But in essence, what we're doing here is we're declaring a type that a user can use. And before actually returning this object here as the value of that type, we're applying some hooks onto the properties. So RGB or get the same hook, which basically caps that color or caps that value. Now we use it. So we have a color variable here that uses the color type, and we assign some values to RGB. R is fine because it's 120, falls within range. 320 is too high, and B minus 25 is too low. So if we go ahead and run that, you'll notice that R is fine, it's 120. G is capped at 255, and B is capped at 0. So as you can see, your users can use this however they please, but knowing that the capping and all that kind of stuff is happening under the hood, which could be pretty productive. Cool. So moving on to the next example, chaining hooks. So basically what happens here is that one hook is going to call the other hook, and you can chain those arbitrarily in any way you want. For example, we have X, Y, and Z. They're all 0 at the moment. We're applying essentially the same hook to X and Y, saying that, hey, look, when X changes, I want Y to be X times 2. And for the Y, we go, hey, when Y changes, we want Z to be Y times 2. And then all we need to do is change one thing. So if we change X, we expect Y and Z to also change. And we're just printing them as an object here, just so it's easier to see visually. And as you can see, X has changed to 100 because that's what we've assigned it to here. Y is double X and Z is double Y. So you can change, you can chain hooks in that way to have like a chain effect or a chain reaction. Cool. Moving on to the next example. So we can also nest hooks. So you have the opportunity to basically create an on-change hook on a variable, on a variable. And basically what's happening here is that you can also check to see if that variable already has a hook. And if it does, you can just simply nest that hook function inside of the new hook function that you're declaring. And what we're doing here is exactly that. So we have an on-change hook for X, which basically just prints that the hook object. And then we're actually looking for that. We're extracting that function out via this method here. So we have x.info, which basically looks into its meta properties, and the on-change hook. So what we're doing is we're declaring current hook to be the on-change hook that we just declared up here. And then we're doing another on-change hook on X, and we're sandwiching that function between these two print calls. Hopefully that's kind of clear what's happening here. And if I run that, you'll see that as we expect, this prints before the first hook is called. The first hook is called, therefore it prints that object, and then this prints after. Now, one thing about that is that this could get very convoluted and confusing, because if you imagine doing this multiple times over and over again, you don't really know what that hook is or what it does, or you have no control over whether you want to remove that hook later on or you want to add something on in a different place. It gets very confusing if you go ahead and do the really deep nesting of hooks. So a better way of doing things is something like example 6. And I'll just comment that in for a second. So example 6 is essentially very similar to what I just showed you with the nesting, but it's a bit more flat and linear, and you can sort of understand it a bit more and manipulate it a little bit better. So we have an object here that has a value of 0 and some functions. That's just an empty array. And then what we're doing is we're going to apply an on-change hook to the value of that object. And what we're doing in that hook is saying, look, whenever the value changes, I want you to iterate through the list of functions and fire them off. That's all we're doing. And this is the for loop syntax for Vortex, if you were wondering. The I is the index, fn is the value, essentially, of each iteration. And then what we're doing here, essentially, is we're just appending some functions into the functions array. We're going to append this function, which basically prints this prints before. We're going to another function that prints the current value, and another function that prints after. And then we're going to go ahead and change value over here and see what happens. And as we expect, this prints before 100 and this prints after. Now, if we want to remove the first thing, right? We want to remove the first function that we've appended, which is this prints before, and run that. You can see that the first part happens as per usual, right? But the second time around, when this is 200, this prints before doesn't get printed because we've removed that. So we don't need that anymore. We've removed it. It doesn't get printed. And this is a lot easier to manage instead of nesting hooks, because then you can sort of arbitrarily change, add, or modify different functions that get fired. Cool. Hopefully you're following with me so far. Only 2 more examples to go, so not too heavy. Example number 7 is actually very, very easy. It's essentially the same thing as what we talked about in example 1, except instead of an onChange hook, we can actually have an onAccess hook. And it works kind of the same way in terms of how the hook function fires under the hood. However, it injects a different object into this parameter over here. And obviously, it doesn't happen when X or the variable changes. It happens whenever the variable is accessed. So for example, in example number 7, if I print that, if I run that, it's just going to print value 100, name X, and this is the object that gets injected into E at runtime, and then we're just printing X, which is 100. So very similar to onChange hooks, except it's on access and instead of onChange. A useful thing you can do with onAccess is, if say you want to keep track of however many variables are used. If you think about web frameworks, for example, and how Vue and React keep track of the variables that get fired, so it kind of keeps track of the different variables that depend on each other. It kind of works in a similar way. JavaScript uses proxies basically to do that. You can do very similar things with hooks. And what I mean by that is, say I want to have a dictionary of variables that have been used and how many times they've been used. So I have a variables use count object over here. It's just an empty object. And then I have X, Y, and Z, which is 10, 20, and 30. And then I apply some hooks onto these onto these variables. That basically, all that's saying is, hey, look, if X doesn't exist in variable use count, make it a 1. If it does exist, just add 1 to it. And that keeps track of how many times this variable was used. And if we scroll down to this little expression over here, basically this is an arbitrary expression. You don't really need to care what that evaluates to, but all we care about is like we're using X, Y, and Z. Sometimes multiple times, sometimes only once. So we're using them over here, and then we're going to print the variable use count. So if I run that over here, funnily enough, this actually evaluates to 10, which is nice and neat. But as you can see here, we've kept track of how many times each variable was used. So X was used 3 times, so 1, 2, and 3. Z was used once, and Y was used 1, 2 times. And that's basically the end of this video. This showcases some of the different things you can use with hooks. So onChange and onAccess are the 2 hooks available in Vortex. Possibly more hooks to come later on. But as you can see, they can already be very useful in certain circumstances. They can be a foot gun, as I mentioned earlier. You just have to keep track of what's happening and make sure you and your user base understands what's going on with what you're providing. Thanks for watching, and until next time.